You are standing in a barn in LaGrange County, Indiana, watching a 67-year-old man named Eli Troyer pull back a wooden panel in the floor of his workshop to reveal 2 copper rods and 2 zinc rods driven into the earth below, connected by wire to a simple circuit sitting on a shelf above them. That circuit powers the LED work light above his bench, the small fan moving air through the barn in July, and the battery bank that runs the water pump for his livestock troughs. It has been doing this since 2006. The copper and zinc rods have not been replaced since 2009. The circuit components cost $5 when Eli built the first version in 1987. The total electrical cost this man has paid in 37 years of operating a productive working farm with a workshop, a water system, and functional lighting is $0. Not reduced, not offset, $0. The device under the floor is called an earth battery. It is a galvanic cell using the earth itself as the electrolyte medium, generating electrical potential from the electrochemical difference between 2 dissimilar metals driven into moist soil. The physics was documented by Alexander Volta in 1800, applied to earth contact configurations by Scottish physicist John Dancer in 1838, in experiments published in the Philosophical Magazine, and was the subject of a formal patent filed by American inventor Nathan Stubblefield in 1898. U.S. Patent 600,457, publicly accessible through the USPTO Full Text Patent Database. That patent describes a ground-based electrical generation system using buried, dissimilar metal electrodes producing continuous electrical output from soil electrochemical potential without any fuel, any moving parts, or any external energy input of any kind. Stubblefield's patent was granted, his demonstrations were witnessed, his device worked. Within 5 years of his patent filing, the investor-owned electrical utility infrastructure being built across America had identified his technology as a structural threat to the metered billing model the entire utility business depended on. Stubblefield died in poverty in 1928, having spent his final decades unable to secure financing from any investor whose capital was connected to the utility industry. His patent expired. His technology disappeared from every electrical engineering curriculum built after 1910 and has remained absent from every one built since. The most documented real-world case of earth battery operation outside Amish communities comes from a telegraph network operator named Alfred Hibbard, who ran a telegraph line across 30 miles of rural Vermont farmland between 1875 and 1891 using no external battery source of any kind. Hibbard, whose operational records were preserved by the Vermont Historical Society in Montpelier and referenced in a 1923 survey of early Vermont telecommunications infrastructure published by the Society's quarterly journal, discovered in 1875 that the earth connection required by standard telegraph grounding practice was producing sufficient current to operate his line without the zinc acid wet cell batteries that every other operator in the region was purchasing and replacing on a quarterly schedule. He documented his discovery in a letter to the American Telegraph magazine in 1876, describing the voltage and current characteristics of his earth connection across different soil types and seasonal moisture conditions, noting that spring and autumn produce the highest output and that installations near stream beds and low-lying agricultural fields consistently outperformed upland installations in dry soil. His letter was published and then ignored. He operated his earth-powered telegraph line for 16 years. When his line was absorbed into a larger commercial telegraph network in 1891, the acquiring company replaced his earth generation system with standard wet cell batteries on the grounds of standardization. The earth system's operating records, showing 16 years of uninterrupted service at zero battery cost, were not preserved by the acquiring company. Hibbard's original letter to the American Telegraph magazine is the primary surviving documentation of what those 16 years represented. Here's the number that changes everything. The average American household spends $1,560 per year on electricity, according to the Energy Information Administration's most recent residential energy consumption survey. Across 123 million housing units, that is $192 billion in annual residential electricity revenue, every dollar of which depends on the consumer having no viable alternative to purchasing electrical power from a metered source. An earth battery producing even 50 watts of continuous output eliminates between $200 and $400 of annual electricity purchase from the average household. The Utility Industries Political Action Committee spent $246 million on federal and state lobbying in 2022, according to Open Secrets data. The investment in regulatory capture that keeps the earth battery illegal to connect to premises wiring is the cheapest insurance policy in the history of American industrial capitalism. The electrochemistry is not disputed by any chemist anywhere. It is standard galvanic cell theory taught in every high school chemistry course in America. Simply applied to a configuration, the electrical industry has ensured no electrical engineering student ever encounters professionally. When two metals with different electrochemical potentials are placed in a conductive medium, a voltage difference develops between them equal to the difference in their standard electrode potentials. Copper has a standard electrode potential of positive 0.34 volts. Zinc has a standard electrode potential of negative 0.76 volts. The potential difference between copper and zinc in a conductive medium is approximately 1.1 volts, identical to the voltage produced by the zinc carbon battery in every flashlight sold in America. The earth battery is a flashlight battery whose electrolyte is the soil between the electrodes rather than the chemical paste inside a sealed cylinder. The chemistry is identical. The configuration is different. The flashlight battery is sold to you at a price that generates revenue. The earth battery uses soil you already own and generates revenue for nobody, which is the complete explanation for why one appears in every hardware store in the country, and the other has been absent from every electrical engineering textbook published since 1910. The soil electrolyte is the variable determining earth battery output, and the element the LaGrange County Amish community has refined most substantially across generations of practical operation. Soil conductivity depends primarily on moisture content and dissolved mineral ion concentration. Dry sandy soil produces minimal output. Moist, clay-rich soil with significant dissolved mineral content produces maximum output. The Amish site their installations specifically in locations where soil moisture is consistently maintained, near livestock water troughs where spillage keeps the soil moist, near downspout discharge points where roof runoff saturates the ground after every rain, and in low-lying areas where subsurface water accumulates through dry periods. This siting practice is the single most important determinant of system performance and the element most commonly neglected by outside experimenters whose attempts to replicate earth battery performance fail because they install electrodes in dry upland soil. The electrode configuration Eli uses consists of copper rods and zinc rods driven to a depth of 4 feet in moist soil with a horizontal separation of 6 feet between the copper and zinc electrodes. The 4-foot depth reaches below the seasonal drying zone in Indiana's climate, maintaining consistent contact with moist subsoil through the driest summer periods. Each copper-zinc pair produces approximately 0.9 to 1.1 volts of open-circuit potential in LaGrange County soil conditions. Multiple pairs are connected in series to achieve useful operating voltage. Eli's installation uses 48 pairs arranged in a series parallel configuration producing approximately 8 to 12 volts at 80 to 120 milliamps under optimal soil moisture conditions, delivering between 640 milliwatts and 1.44 watts of continuous electrical power into his battery bank. That output requires honest characterization. 1 watt of continuous generation across 24 hours produces 24 watt-hours of stored energy. Across 30 days, it produces 700 lb 20 watt-hours. A 100 watt-hour battery bank fully charged by earth battery input over 4 to 5 days can power an LED work light at 8 watts for 12 hours, a small fan at 15 watts for 6 hours, and charge communication device batteries, all from a generation source that costs $5 in materials and produces power continuously without fuel, maintenance, or any ongoing input beyond the electrochemical potential of the soil it sits in. Eli's farm does not run on earth battery power alone. It runs on earth battery power supplemented by a small solar panel array for peak load periods and a wind generator on the barn roof for overnight charging. The Earth battery is the baseload generation source running continuously regardless of weather, providing the slow, steady accumulation of stored energy that the intermittent renewable sources supplement during their productive periods. The combination produces a power system with no fuel cost, no utility connection, and a resilience profile that no grid-connected household can match, because no weather event, no grid failure, and no utility pricing decision affects any component of it. The scientific documentation trail runs from Volta's 1800 Royal Society letter through Dancer's 1838 Philosophical Magazine publication, through Stubblefield's 1898 USPTO patent continuously through published peer-reviewed science and formal patent records, and then stops completely in the mainstream literature after 1910. Not because the physics changed, because the industry built after 1910 had no use for a generation technology that eliminated the need for the industry. The contemporary regulatory dimension requires specific and honest explanation because the illegality referenced in this video's title is real but frequently mischaracterized. The Earth battery is not illegal to build. It is not illegal to own. It is not illegal to operate as an off-grid power source for loads not connected to premises wiring. What is illegal under the National Electrical Code Article 230 under IEEE Standard 1547 governing distributed generation interconnection, and under the interconnection tariffs filed by every investor-owned utility with their respective state public utility commissions, is connecting any generation device whose output characteristics have not been evaluated and approved under the applicable interconnection standard to the premises wiring of a grid-connected building. The Earth battery has no evaluation pathway under IEEE 1547 because IEEE 1547 was written for solar, wind, and storage systems and contains no provision for galvanic earth contact generation. It cannot be approved for grid-connected premises wiring connection, not because it is dangerous, but because the approval pathway does not exist. The people who wrote the approval pathway had no financial interest in creating one for a $5 device that competes with their metered product. Eli Troyer's installation has no utility connection. His barn has no utility meter. His farm is entirely off-grid, and has been since the Lagrange County Old Order Amish District's Ordnung determined in the 1960s that grid connection created a financial dependency relationship with outside institutions inconsistent with community values of self-sufficiency. That religious and cultural conviction produced, as a practical consequence, a community that spent 60 years developing the off-grid generation and storage technologies that mainstream American culture is now discovering it needs in an era of grid instability and rising electricity prices. The Amish did not develop Earth battery technology because they were trying to be progressive. They developed it because they were trying to be independent, and independence required solving the same engineering problems that grid independence requires today for entirely different reasons. The construction of a basic Earth battery system begins with electrode selection and site assessment. Copper pipe in half-inch diameter available at any plumbing supply house and zinc-coated steel pipe in equivalent diameter available as galvanized steel pipe at any hardware store are the most practical electrode materials. Electrode length should be a minimum of 4 feet, with longer electrodes preferred for deeper moisture access. Site assessment focuses on soil moisture consistency across seasons. The installation site should be probed with a soil moisture meter at depths of 2, 4, and 6 feet during the driest period of the local summer. If soil moisture at 4-foot depth reads above 20% volumetric water content during the driest summer period, the site is suitable for year-round operation. If moisture drops below 15%, supplemental moisture management through buried drip irrigation from roof runoff collection will be needed. Electrode pairs are installed with copper and zinc rods driven vertically into the soil at 6-foot horizontal separation. Multiple pairs are installed in a grid pattern with pairs separated by 10 to 12 feet to prevent electrolyte depletion zones from overlapping between adjacent pairs. Pairs are arranged in series parallel configuration to achieve the desired output voltage and current balance. A 12-volt target operating voltage requires approximately 12 to 14 series connected pairs given the 0.85 to 0.90 volt operating potential per pair that typical soil conditions produce under load. The output connects to a charge controller designed for low current input, specifically a controller rated for input currents below 500 milliamps at 12 volts, rather than standard solar charge controllers designed for much higher input currents. Specialty low-current charge controllers are available through marine electronics suppliers serving sailboat operators using small alternative generation sources for battery maintenance charging. The total material cost for a 6-pair system producing approximately 6 volts at 50 to 80 milliamps, sufficient for LED lighting and small device charging, is under $30 in electrode and wire materials excluding the charge controller and battery bank. The $5 figure in this video's title refers to the cost of a single copper-zinc pair with wire connections, the minimum viable demonstration of the principle rather than the cost of a practical generation system. Nathan Stubblefield filed his patent in 1898. The USPTO granted it. His demonstrations were witnessed by credible observers, including journalists from the St. Louis Post-Dispatch, who reported on his wireless telephony demonstrations in 1902. He died in poverty in 1928, having spent 30 years unable to secure development funding from investors whose capital was connected to the utility infrastructure his technology threatened. John Dancer published his Earth galvanic experiments in the Philosophical Magazine in 1838. Alexander Volta documented the foundational electrochemistry in a letter to the Royal Society in 1800. The science is 224 years old. The practical application is 126 years old. The patent record is 126 years old. The absence from every electrical engineering curriculum built since 1910 is 114 years old. Eli Troyer's barn has been powered by copper and zinc rods in the ground since 2006. His workshop light is on. His fan is running. His livestock troughs have water. His utility bill is what it has always been for every Amish farm in LaGrange County across the century that the investor-owned utility grid was being built around them and to which they were never connected. 0. Drop your state in the comments and tell me what you pay for electricity each month. Tell me whether you have a barn, a workshop, or any outbuilding you power from an extension cord run from the house, because every one of those structures is a candidate for an earth battery installation that eliminates that extension cord permanently. Tell me if you have moist soil on your property because the electrolyte for the device that could reduce your utility bill is already under your feet and has been since before the first utility pole was installed on your street. The copper pipe costs $3 per foot. The zinc pipe costs $2 per foot. The soil is free. The electrochemical potential between copper and zinc has been 1.1 volts. Since before Alessandro Volta measured it in 1800, it will be 1.1 volts after every utility company currently billing you has been restructured, regulated, or replaced by whatever comes next. And it is available to anyone willing to drive 2 rods into the ground and connect a wire between them, which is exactly what Nathan Stubblefield did in Murray, Kentucky in 1898, and exactly what Eli Troyer has been doing in LaGrange County, Indiana since 1987. The rods cost $5. The ground is everywhere. The patent expired in 1915, and the only thing that has kept this technology out of every electrical engineering curriculum, every utility research program, and every government energy policy document for the 114 years since is the $192 billion annual reason. The people writing those curricula, running those programs, and drafting those policies had to leave it out.